Hello everyone, thanks for joining me. My name is Philipe Ozil. I'm a developer evangelist with Salesforce. I'm French also, by the way. And it's my great pleasure today to present to you Lightning Web Component testing. And my presentation has a little play on word. It's called Quit Jesting and Test Your Lightning Web Components. Now, those of you may wonder why I chose this particular title. Well, the thing is, you are testing Lightning Web Components with something called Jest, thus the joke. Now, I'd like to remind you that Salesforce is a publicly traded company, so please make your buying decisions based on what is commercially available in the product and not on what I'm going to say. The good news is that we should be safe from forward-looking statements because I'm talking about features that are already part of the product and are already GA. With that, here's the agenda for today. First, I'm going to talk about the testing environment, comparing it with the production environment. Then I'm going to explain a bit how you write tests with Lightning Web Components. And finally, I'll share some common patterns and tips that can help you write great tests and efficient code coverage. Let's start with this testing environment. So I'm going to set the stage, and I'm going to explain a bit how this is different from what you're used to when you're testing Apex or testing Lightning components. The first thing that is important to realize is that we're operating in a very different environment. When you're doing production work or runtime work, you are on the Salesforce org. So you're in the browser, you're connected to the cloud, you're ever running on a production org, sandbox, or scratch org. But when you're doing testing for a Lightning Web Component, it's actually something very different because this time you're working on your machine, on your local machine. So what this means is that for doing unit testing with Lightning Web Components, you can actually do this offline. So if you pull your Ethernet cable, if you just shut down the Wi-Fi, you can still run your Lightning Web Component test. You do not need to have a connection to the Salesforce org. That's a huge difference compared to the other testing environments. How does this work? Well, there are key components that compose the infrastructure. The first thing is Node.js. We're running a JavaScript framework, so to support tests for a JavaScript framework, we need Node. So that's the server that is going to run on your local machine. Then we're using an extension, framework called Jest. This is a testing framework. I will talk more about it in the future. And we're adding an add-on, an extension to this particular framework, which is called SFDX Jest-WC. This is an extension that Salesforce provides on top of Jest. And finally, there are optional dependencies. You do not need to have them if you don't want to, but they're actually very recommended. The first one is ESLint. I'll talk also more about it. And we have some extensions which are made also by Salesforce to add specific rules related to Lightning Web Components. And then, since it is actually running on a Node.js server, you're totally free to use any other tool that is supported by JavaScript. So you can add your custom dependencies. If you want to add something additional for code coverage calculation, you can add whatever you want there. So that's the overall environment. Now, what is the advantage of this particular infrastructure? Well, the first thing is that it is actually totally standard. It's not something that only Salesforce does. If you compare that to Lightning testing like we had for Aura, which was custom built by Salesforce, this is totally standard practice. So what this means, in fact, is that you can use tools that have been used for the last 10 years and even before to test your framework. And Jest is a very good example of that. Salesforce hasn't built Jest, but you can use Jest because it's JavaScript. So you can use all of those popular tools that have been tested and proven, and you can actually extend those tools also if you have custom tools you want to build on that. Another great advantage of this environment is that it runs on your local machine. So that means you're forced to actually run your test in isolation. So that means that every developer who is going to run your tests will not have access to your org. So the test will behave the same way for everybody, and you're forced to do proper unit testing. You're not doing integration testing with your database. So it's actually a good testing practice not to have platform access. Another thing that is important to know is that the tests you're going to write are actually not tests that are going to be deployed on the Salesforce platform. So that means you have to adopt some revision control somehow. So they're going to be pushed in Git or SVN or whatever is your preferred revision control system. But it's your job to keep track of that. And the good news is that generally it's a widely adopted technique because you generally run as in Salesforce DX project and your code is already checked in source control. So you should be safe for that. The last important bit that is also a big difference when you compare it to Apex testing is that there is no required code coverage. Why is that? Well, the thing is, When you do Apex, and if you do something stupid in Apex, you can really destroy your data. And the impact of having something that is buggy in Apex is way more dangerous than if you just have a user interface component that doesn't display the right data. So we do not force our users to have code coverage to deploy a component in production. It is your responsibility to be a good citizen and actually do it. Now let me talk about a bit the different components. First, Jest. So Jest is really the centerpiece of what we're doing for testing. And it is, I can say easily, the most popular testing framework. It's being built by Facebook. It is open source, and so it means that it's easy to extend and to customize. Now, it's very good because it's actually super fast. The way it's built, it runs tests in parallel, and also it has a great UI to report errors and do code coverage built in. Great documentation, so there's an excellent community that helps you on writing efficient tests. And the good news is that all the documentation you can find online, which applies to standard JavaScript, works also for Lightning Web Components. There are a few things that are specific to Lightning Web Components, but the vast majority of what you can read in documentation will apply to your work in Salesforce. So the way Jest works is first with vanilla JavaScript, so plain old JavaScript, and HTML. And by the way, this is actually simulating the behavior of a web page by having something called JSDOM. So it's simulating the behavior of a web page being rendered, but just in memory. There's no browser on the testing environment. And it simulates the page building. Now, what is very cool about this is that you can have access to the browser API. So if you document getElementById, for example, JSDOM is actually simulating all of that, but you don't have a real page working on your browser. Now that's the basics. We use Jest to that. And what we did is that we had to add an extension to support things that are very specific to Lightning Web Components. And there are mainly two things that are specific to Lightning Web Components here that we're adding. The first one is mocks for base components. So if you're testing something, for example, with a Lightning input field, well, Lightning input field is not just pure JavaScript, and you don't have access to the source code of Lightning input field. So you have to simulate that. And to simulate that, we're using those mocks that are built in the extension. Another great addition to Jest is the simulation of mocks, wires. So when you want to call Apex code, you can simulate those Apex code, and remember that you're working in isolation, you're not connected to your org, so you can actually simulate the data returning, the org returning data to your wire calls. So you don't have to connect to the internet, you can simulate what is returned by the server with wire mocking. Then there are additional components. I'm giving an example with ESLint. This is not mandatory. You don't have to use it if you don't want to, but I think it's really good practice. ESLint is called a linter, and the job of a linter basically is to tell you whether your code is properly formatted, whether you're doing the right things. Here I'm giving out an example with something that is kind of a bad practice. In Lightning Web Components, you do not want to call getElementById, and especially you don't want to use document functions. Why is that? Because you don't have access to the top-level document. You're inside a component which is isolated from the rest. And then you don't work with IDs because the IDs are regenerated by the framework, so they're not reliable. You cannot, some ID that you use here isn't going to be some ID because the framework will calculate IDs dynamically when you render components. And so what ESLint does is that it brings this little tooltip and underlines the error messages by providing rules, and that tells you that you should not use those things. This particular error comes from our plugin. So you can see actually the contrast ratio is not very good, but it's actually coming from Lightning Web Component rules, LWC rules. So this is a custom rule that we added on top of ESLint to tell you why your code is not correctly formatted. So this is super useful because it helps you to detect flaws in your code, flaws at implementation time, but also flaws at testing time. So for example, if you write a test code with no assertion in your test code, well, there's a problem. The test isn't testing anything. So the ESLint extension will tell you that. It's telling you, well, this test doesn't have any assertion, so you should fix it. So I think it's very valuable to have it, even for testing. How do you install this testing environment? Actually, it's super easy. The first thing that you have to take into account is that there's a requirement for setup. The first thing is that you have to have Node.js installed and Salesforce.dx, a Salesforce.dx project. And then there are just 3 commands that you have to run. npm init, which creates the structure of a node project. npm install, which installs the basic dependencies of the project. And then you install the Jest extension for Salesforce, for Lightning Web Components. 3 lines of code, it takes less than 5 minutes. My session time is a bit short, so I don't have the time to demo it live, but it's super easy. And the last thing you have to do is actually add some scripts that help you to run the tests. So here I'm showing you an example. It's a subset of all the tests you have to, of all the commands that you get. But the 3 most important ones are unit test, just to launch the tests, then watch, to actually detect changes in your code, to rerun the test when you change your code, and finally coverage, which gets you the code coverage for your tests. Now, that's how you set up the environment. Now, let's see how you actually write those tests. To write the tests, it's actually very easy. So there's a common folder structure that you have to follow. And when you're working on a DX project, there's a folder, a top-level folder called LWC, which contains all your Lightning Web components. So here, what we're looking at is a hello component. And this hello component has the standard file. So there's a HTML, JavaScript, and JS meta file, which contains the metadata for the file. And then there's these 2 extra bits. So there's a subfolder called __tests__. This is supposed to host all the test files for this specific component. And then as a convention, we have 1 test file. We could have more than 1 here, but generally we only have 1. Hello, the name of the component, then .test.js. This is a JavaScript file which contains all the tests that are going to run for hello.js. Now, one last thing, and I remind you of that. This particular test folder is not going to be deployed on the platform. So it's important to remember the test is only running on your computer. It's not getting pushed with the metadata, with the rest of the component code. This is staying on your local machine. Now let's take a look at this file. There are some top-level components that are very important. The first level is test suite. So a test suite is a collection of tests, and you can have more than 1 in a file. They regroup the tests in some functional, meaningful way. So here I've just used a syntax which is not very meaningful. I just called my test suite C-hello. But normally you would want some more descriptive name. In this particular instance, this is a super simple component, so we're only having 1 test suite which regroups all the tests. Then just like you have for Apex testing, we have tear down or setup instructions. So this is a block of code after each that is going to be run after each test. This is optional, but most of the time you have it, and generally you have to use it because you're just cleaning up the web page that runs the test. And finally, the last bit that is important is the it instruction, which contains individual tests. So you can have multiple it instructions. And the way this is structured is that you want to have a sentence in here that is actually something you can read. So it needs to be a text that you read, and reading that text immediately tells you what the test is doing. So it displays greeting, and then you know what the test is going to do when you read the name of the test. You don't necessarily need to look at the code of the test. The name of the test should tell you what it's doing. And this is super important because as your project grows, there's going to be hundreds of tests, and when a test fails, the label of the test will show up. And so you need to know what doesn't work. So it does not display greeting would be a good indication of what is going wrong with this particular test. Now let's see how you actually write the test when you're inside your it statement. Well, the first thing is that you have to take into account is there is a common pattern to write those tests, and a simple way to remind you of how to do that is a given, when, then. 3 words put in the right order, which tells you how to structure your test. The first thing that you want to do is to prepare your test environment. So prepare, for example, mock data, put your components in the right state. Then there is the when phase, which is the behavior you want to test. And finally, the then, which is the place where you write your assertions. So normally, you only write assertions in 1 block at the end. There are some exceptions to that rule, but generally, you write the assertions at the end. Let's see those phases more in detail. So I'm going to take an example here. We're generally doing one thing in most of tests, when we're doing the given. The first thing to do is to actually create the element. So you start with a blank HTML page when you're inside your test. So the first thing you want to do is to actually create the component that you're testing and attach it to the page. With create element, you actually create your component. So here we're testing a component called contact list. So we create that component, and then we can set public properties like this one, for example, and you can attach the new component to the HTML page that is used for a test. That's a really common scenario, and this is generally what you do for most of the tests. That's the first thing you do. You create the component, you configure it, and then you attach it to the page. Then you move to the second phase, the when phase. This is where you test the behavior. So you can do multiple things depending on your scenario. Here I give you 3 different examples. It can be simulating a click on a button. That's the first example I gave here. It can be entering text in an input field, for example, or it could even be if you have a wire to send mock data in your wire call. So don't pay too much attention to the code, but these are just examples of what you can do. I will go on a really concrete example next in the demo. Finally, the last phase is the then phase. And in the then phase, it's actually very simple to write your test because we're using assertions in something called a fluent syntax. So the idea is that you want to be able to read the line, and actually it turns out to be a sentence, so you know exactly what it does. You see, expect div content to be hello and then constant, so hello world, for example. Or expect mock select handler to have been called 1 time. This is called a fluent syntax because you can read it and you can understand it even if you don't know how to code. And what is important here is that it's composed of 2 things. There is the expect statement, and then there are something called matchers. And the matchers are what constitutes the test and the conditions that must match or must not match. So for example, not to be null is a matcher. So you compose those matchers to write the test instructions. And you could do the same thing, of course, with just a single assertion, but the way you would structure your assertion would be very hard to read. With that fluent syntax, it makes tests very easy to read and understandable. Let me show you an example of that. I have a bit of time, so I'm going to jump to a small demo. Now, in this demo, I'm going to use one of the sample applications that we're offering. These are part of the sample gallery. You can find those on Trailhead. And I'm going to focus on one that is called Recipes. So Recipes is it's an application that contains a lot of small code examples, very short examples, which are very specific to one particular task. It's open source, so you can check the source code, and you can also check the test code, sorry. Let's have a look at this one. Oops, this way. So this is Recipes that is deployed on an org. So you can, yeah. Oh, sorry. All right. Let's see. That should be better. Yes. So let me go back quickly. Okay. Oh, let me stop the. Okay, let me stop the presentation mode, and that should help. Thanks for telling me. I could go on for days otherwise. All right, so this is the sample gallery. You can find it on Trailhead. There's a link, sample gallery. And what I'm going to show you is recipes. So recipes is the set of small examples. So each card here is a small example. I'm going to take the most basic thing here to show you a simple test. But if you explore this sample gallery and explore the different recipes, you can find things that are very much advanced. So I'm just going to look at this one, the most simple hello world here. And we're going to jump to the code, oops, this way. And we're going to take a look at the component. So let's just first look at our component itself. The component is super simple. It just displays hello. So let me just increase the font size so that everybody can see. I'll remove. So just hello and then a property here with the name of the person, for example. So if you look at the JavaScript code of the component, well, this is just a property with a hard-coded value world. Simple, right? Now, let's look at the test. So in our __test __ folder, we have this file, which is here. And this is the example I gave earlier. It displays greeting. So the first thing we do in a given part is create the component and attach it to the page. And then we do our test. So there's no real given phase in this particular, there's no when phase in this particular test because it just displays by default, so you don't have to do anything to trigger the behavior. Now, what we do here then is that we retrieve the element, the div element in our tag, and we just check the content of this div element, and we check that it's hello world, so it matches what is supposed to happen. Now, let's actually run this thing. So I'm not going to run all the tests because there are a lot of tests in this particular instance, but I'm going to show you a new feature of Jest, which is very helpful, which is called watch. So I'm going to activate watch mode. I have a terminal running here. And what watches does is that it will check automatically my code, and it will rerun the tests every time I modify the source code. So if I save my file and modify it, it will rerun my test. So watch is ready now. And what I'm going to do is I'm going to change the content of my test. So remember, we're checking for hard-coded string hello world. So if I change here and write Paris here, the test should fail. I'm going to save. The tests are automatically triggered, and in a couple of seconds, we should see an error message. Here we go. Now, if I open this, you'll see a nice UI. We should see hello world, but we're seeing hello Paris. So this is a very convenient way to do the test, and it's the description of the error is also very visible, very identifiable, and this is a convenient way to run your test. Of course, you can also run test coverage, you can run all the tests, but that would take more time, so I'm not showing that. All right, back to the slides. So we've seen the structure of tests, we've seen how to run tests. Let's now go into some common practices and good patterns that you can adopt. The first thing that is important is that when you write a lot of tests, there are two types of things, two types of behaviors that you're going to test in your code. The first one is DOM inspection, and the second one is really testing the logic itself. So when you do DOM inspection, you want to actually check how the HTML looks like, so how the DOM tree looks like. So you want to check, for example, for rendering logic. So for example, if you have iterations, if you have conditional rendering, this is what you're going to check with DOM inspection. Now this is super important because this is what is being shown to your end user, but it's also a bit difficult to do because there's no test coverage, so you don't know exactly what part of templates you're testing or what you're missing in your tests. And it's also harder to maintain because if you're doing tests and you're basing your tests, for example, on CSS classes, when you select DOM elements, these CSS can be modified and because your code will probably evolve and it's easy to break that test. So it's important, but it's also a bit more difficult to do. And then the last thing, which is easier to do, is testing the logic. Because when you test the logic, you're just testing plain old JavaScript. So you can just work with code coverage and see what are the parts of your code that are not covered. It's easy. So remember to do both. Make sure you have good code coverage, but also make sure that your DOM is also rendering nicely. That's the two things you need to do. Another good practice is when naming tests, you really want to pay attention to the way you name things. So remember top-level suites, test suites, and then test under that. And you can have a test suite in a test suite, that's perfectly okay. But this is important because when you have tests that are failing in a large project, you really want to be able to identify very quickly which ones are the tests that fail. So the test suite is the component itself, and maybe under that some specific scenarios. And the test name is really a sentence that tells you exactly what you're doing. So with expectations and a scenario. So when you're doing that, what should happen, basically? That's the way you should write the test name. Another good thing that is important to do is when you're doing testing data, there are a few things that are really important. The first one is actually testing with realistic input data. Don't use foo, bar, or toto, for example, in French. Don't do that. Try to take meaningful names because this is likely what your customers or users are going to do. So try to have variations of those things, but make sure they're realistic and not just same old value everywhere in all your tests. Make sure also you use different values across your tests to cover the most ground you can. Use constants when you're doing tests. So the example I gave you with hello world before wasn't a good test because it wasn't using a constant. So you should think about using a constant when you're doing a test. Instead of having hello world in a simple string, you should use a constant to have the world part as a string. Because you're going to write it several times in your component and you want to make sure you don't have a typo in there and it's the same value everywhere. Finally, when you have a lot of test data, what you want to do is generally extract it to JSON files. You can import JSON files like you would import any other files with an import statement, and you can refer to those files directly in your tests to load this data. So imagine you have to test a list of contact that is being retrieved. You don't want to type the list of contact in your test code in your JavaScript file. You want to export that to a JSON file and load it and return it in your wires, for example. Another thing that is important when you write tests, it's not the end goal of writing tests is not to have 100% code coverage. It's useless. You don't need to get 100% to have something that works and that is reliable. What you want to do is identify things that are the most valuable to test first, and then, of course, if you have more time, you can increase code coverage. But you first want to test public methods, things that are exposed to the parent components. And then you can also test the template, so where the rendering logic works. If you have iterations or conditional rendering, you want to test that. And also test events that are going back up to your parent components. These are really the main things you want to test. That's the minimum. After that, if you want to test the inner logic, well, it's maybe not so useful because your component renders correctly in the given testing conditions. With that, I want to conclude. So we've seen today the difference between Jest and the testing environments with Lightning Web Components and the other testing frameworks. We've seen that it's local machines, local environments, so safe from getting. It's safe because it's portable, actually. And the last thing is that also you can actually use those tests to write behavior-driven tests. So you can actually use the given, when, then pattern to write your test and have a really good syntax. The last thing is that, remember, you don't have to work on full code coverage. Focus on black box testing. Focus on what is publicly available in your component and leave the implementation details on the side. What's next? Now that you know how to write tests and you have written some tests, the next phase is what you can do after that is add preacher. This is a good extension that helps you to reformat the code style, the formatting of the code, sorry. And you can use that because it's very convenient to have that when you work on a team and different people have different syntaxes, like do you skip a line after opening a bracket, do you do something like that? Well, with preacher, there's a set of common rules that work for everyone, and this enforces the code style for a larger team. So this is actually very helpful. It's not functional, but it's actually helpful because the code looks the same everywhere. Next phase also is to actually start CI. Jest runs fine on your local machine, but it's also something you can hook up to a continuous integration system, and all continuous integration systems will support that thing. So it's easy to set up. There are lots of examples. And again, it is not specific to Salesforce. That's actually a good news because a lot of people have already written tutorials on how to set up Jest on a node server in a CI environment. You don't need to read our documentation, Salesforce documentation for that. It's available online. And last thing that you want to do also, when you have some good coverage, you want to study the evolution of that code coverage. Maybe you have a good percentage today, but tomorrow when you add a lot more code, will the code coverage still be okay? That's something you have to monitor. Because as your project evolves, the code coverage might lower if you don't write enough tests. So you want to maintain a good average for your code coverage across time. That's it. I'm going to leave you with a few resources. The first one is the Jest website. So this is the official site for the library. It contains tons of good test examples, this description of all the matchers. So how to test, for example, asynchronous code, how to test timers, things like that. Very advanced examples, also very simple things. The good thing is that Salesforce doesn't have to write all of this documentation. It exists already with Jest. And there are tons of examples for that. Next link is the sample galleries. So that's what I showed you earlier. And I want to insist on pointing out that recipes is the best one because recipes has all the small examples for particular scenarios for testing. So you can see easily how to test, for example, a wire call, how to test a list with parent-child relationships, things like that. So these are all isolated. There's test code in the sample app on GitHub that you can check out. Another other good resources that are very generic, the Salesforce developer blog. We've written a couple of articles on how to set up the testing environment, so you can look for tests there. You'll find some. And then Trailhead. This is a basic resource for developers to find how to write Lightning Web Components. I must tell you, forward-looking statement, for now there are no modules dedicated to testing yet. We are in the process of writing those, but they're not yet. They're not there yet. This should be fixed in the near future. So keep on looking for Trailhead because there will be some content on testing soon enough. With that, I'd like to thank you. I'm going to take questions if you have any.